Welcome students. In the previous class we have derived the equation of torsion for solid shaft. Now let's see if we take a hollow if we take a hollow circular shaft. I mean, if we take the hollow circular shaft, then what will happen in the what kind of changes happens in the torsion equation? Okay, so this is the cross section of the shaft. Basic cross section is R. This is the internal cross section. External dia is D. Internal dia is small d. Okay, so up to the equation 1, that is tau by R is equals to g theta by L. Up to this the equation will remain same. Up to this the process will remain same. This is capital R and this distance is small r. This distance is small r and this is a capital R. Okay, so capital R is the outer radius of the shaft, small r is the inner radius of the shaft. Tau is the shear stress at radius r. Okay, now we are taking similarly an elementary ring or elementary strip, circular strip or circular ring at a radius x. This is the x distance from the center O. This is x. Okay, this is the elementary strip or elementary ring, whatever you can say. Okay, and the thickness of this elementary strip ring is dx. Now the turning moment that is td, the turning moment td becomes similarly tau x 2 pi x dx into x, as we have done in case of solid shaft. Now we are going to integrate this equation 0 to t. Td is equals to, but here the integration limit is from the small r to capital R. That means for in case of solid shaft, this r becomes 0 because this that one's will be the that one's that will be. So now we are going to integrate this equation, that is integration 0 to t td, and in right hand side the smaller limit is small r to capital R. Okay, 2 pi x tau x dx, sorry, x square. Now the value of tau x we all already know, that is tau by r is equals to tau x by x. So tau x become tau into x by r. So integration small r to capital R 2 pi tau x cube by R dx, and that becomes t equals to 2 pi tau by R to the power 4 minus small r to the power 4 by 4. Okay, so again we can write the so can write t equals to, now converting this all radius into the diameter, so we can rearranging as pi by 16 into tau into d to the power 4 minus small d to the power 4 by capital D. This is the torque value, and from the polar moment of inertia relation we can write J equals to pi by 32 capital D to the power 4 minus small d to the power 4, or we can write pi by 32 pi by 2 r to the capital R to the power 4 minus small r to the power 4. This is the value of J. So we can write from suppose this is equation 3. So from equation 3 we can write T equals to tau by R into J. That becomes T by J equals to tau by R. Equation 4. Now combining equation 1 and 4, we get T by J equals to tau by R is equals to G theta by L. This is the torsion equation for hollow shaft. Thank you. Welcome students. Now the topic is torsional rigidity. What is torsional rigidity? From the relation we know that T by J equals to G theta by L. So theta becomes TL by J, TL by JG. Here the G, L and J, these are the constant for a given shaft. Okay, for a given shaft material, G is the rigidity modulus, is a constant. I length, obviously it's a constant for a given shaft, and J is the polar moment of inertia. Obviously it depends on the diameter or radius, so obviously it's constant. So the angle theta of the twisting moment, this theta, is proportional to the twisting moment, and the quantity, that is Gj by L. Theta is proportional to the T, and the quantity Gj by L this is known as, I mean, the reciprocal of this thing, that is Gj by L, is known as torsional rigidity. Torsional rigidity. Okay, and this torsional rigidity is represented by K, that is Gj by L or T by theta, is called torsional rigidity. Hi students, this is Joydeep Sir again, and the topic is power transmitted by the shaft. So we all know that power, that means P, is equals to, for a rotational mechanics, we know that P equals to torque into the angular speed, that is omega. If the shaft is rotated at a speed of capital N rpm, at a speed of capital N rpm, so the value of omega becomes 2 pi n by 60. The value of omega becomes 2 pi n by 60. So the power P is become 2 pi nt by the power P is becomes 2 pi nt by 60. Now if the value of T is F into R, force into the radius, so the equation of power becomes 2 pi n F into R by 60. So watts. Okay, thank you. Modulus of rupture. What is modulus of rupture? The maximum fictitious shear stress calculated by the torsion formula by using the experimentally found maximum torque required to rupture the shaft is called the modulus of rupture, and this is this equation, that is tau r, gives the fictitious value of shear stress at the ultimate torque, because the torsion formula, that is T by J equals to tau by R, is not applicable for beyond the limit of proportionality. This equation, that is T by J equals to tau by R, is not applicable beyond the limit of proportionality. Okay, so that's why we are telling this tau R value is a fictitious value, because at the ultimate torque, the shear stress is we can't calculate the shear stress experimentally, but mathematically that becomes this by this torsional equation. Thank you.